Hello everyone, and welcome to this presentation on the history of electricity. Today, we will go through the key moments of this fascinating history, from the early observations of electrical phenomena in antiquity to the technological advancements of our time. Electricity is the result of discoveries and innovations that have profoundly transformed our world. Let's start with the beginnings. Around 600 BC, Thales of Miletus, a Greek philosopher, observed that by rubbing a piece of amber with a cat's fur, he could create sparks and track small objects. This phenomenon, which he named electron, a Greek word meaning amber, is the origin of the term electricity that we use today. This observation highlighted two essential concepts: the flow of electric charges and the attractive force between these charges. What Thales observed in the form of a spark is indeed actually a manifestation of a current, a flow of electric charges in the air. These attractive forces reveal the existence of an electric field, denoted by capital E, which is generated by a difference in electric potential between 2 points. To better understand these concepts, let's make an analogy with a hydraulic circuit. Voltage can be compared to the height of a column of liquid that exerts pressure, while current is similar to the flow rate of this liquid that flows. Electrons, which are carriers of negative charges, play the role of molecules in this liquid. The history of electricity progressed significantly in the 19th century, with major advancement the invention of the Voltaic pile by Alessandro Volta in 1800. This pile is the first source of continuous, stable and reliable electricity, marking the beginning of modern electricity. Volta demonstrated that it was possible to produce a continuous current that could be used practically. These experiments demonstrated that electricity could not only cause chemical reactions such as the separation of water into oxygen and hydrogen through electrolysis, but also generate heat and light, thus laying the foundations for modern electric lighting and heating. The invention of the battery allowed for the understanding of the concept of electric power, defined as the product of voltage in volts and current in amperes expressed in watts. To illustrate this, one can imagine a waterfall. The higher the waterfall, the voltage, and the greater the flow of water, the current, the greater the power of the impact will be. Another decisive turning point in the history of electricity is the discovery of electromagnetism, which establishes a link between electric current and the magnetic field. Scientists like Faraday, Maxwell, and Tesla contributed to our understanding of this phenomenon. One of the most important applications of electromagnetism is the invention of the electromagnet. Unlike a traditional magnet, an electromagnet can be turned on or off by controlling the current flowing through its windings. This innovation led to the creation of the first electric motors as early as 1826, allowing the conversion of electrical energy into mechanical energy. Electric motors rely on the principle of reversibility. They can operate either as a motor, converting electricity into motion, or as a generator, converting motion into electricity. This principle paved the way for the creation of the first electric machines essential for industrialization and mass electrification in the 19th century. With the increasing electrification, the issue of electricity distribution becomes crucial. The transport of electricity over long distances poses a major problem, with energy losses primarily in the form of heat due to the Joule effect. James Prescott Joule formulated this phenomenon in 1840, showing that losses in a circuit are proportional to the square of the current. The invention of the transformer solved this problem. A transformer, consisting of two windings coupled by a magnetic field, allows for the modification of voltage and current levels without significant energy loss. By increasing the voltage to decrease the current, it becomes possible to transport electricity over long distances with minimal losses. This technique is essential for safely delivering electricity from power plants to homes. The 20th century marked the beginning of the electronic era with a key invention, the transistor, in 1947. This component revolutionized the industry, paving the way for modern electronics and computing. These advancements had a direct impact on the production and consumption of electricity. For example, transistors enabled the development of semiconductors for solar panels, and power electronics facilitated the construction of wind turbines. Electric cars paired with high-performance batteries now allow for energy storage and even returning it to the grid through systems like vehicle-to-grid and vehicle-to-home. These technologies are at the heart of reducing the environmental impact of energy production by promoting renewable sources and optimizing the management of electrical networks, the smart grid. In conclusion, the history of electricity is a human adventure marked by discoveries and innovations that have radically transformed our society. From the first sparks Thales to worldwide electrification, through the invention of the Voltaic pile and electric machines, each step has brought humanity closer to a greater mastery of this form of energy. Today, as we face the challenge of climate change, electricity, thanks to new technologies, remains more than ever at the center of solutions for a sustainable future. Thank you for your attention, and I hope this video has helped you better understand the foundations and evolution of electricity.